So up until now, we've been dealing with just right triangles because our SOHCAHTOA Pythagorean theorem only works with right triangles. But let's face the reality of triangles. We don't always deal with just right triangles. So how can I find missing sides and angles of any triangle? And that's where these law of sines and cosines come in. So what we want to do is we want to look at any old triangle, doesn't have to be a right triangle. And what I want you to see is we're going to be talking about angles and their opposite sides. So opposite of angle A is going to be side A. Okay, opposite of angle B, we're going to call that B over here. And then opposite of C, we're going to call this side length C. And maybe to make it clearer, let me color code the angles too. Okay, so what I want you to again see is the relationship between angles and its opposite sides. So that's angle A across from side A, angle B across from side B, angle C across from side C. And we're going to first talk about our law of sines. And what it does is it just creates a proportion. So let's write this down. So this law of sines tells us the sine of angle A over the length of A equals the sine of angle B over the length of B, which is equal to sine C of angle C over the length C. So we can use that to find measures of angles or sides in any triangle depending on the information given. So in general with law of sines, you're going to need a couple angles or couple sides in a certain formation. We'll talk about that in a little bit. All right, so let's go ahead and look at example 1, and I want to find FG. So I want to find that length. Okay, so what I can do is I can take a look at the triangle and say, well, it's not a right triangle, so I can't do SOHCAHTOA, but I can use the law of sines because this FG over here, it has an angle 32 with it, so I can do sine 32 over FG, right? And make that equal to a ratio of another angle and side. So take a look at another pairing. So I've got angle F. And what is the side opposite angle F? Well, that's the 40, right? So I can say sine 40 over, or sorry, sine 39, excuse me, sine 39 over 40. All right, so then I can create a proportion so I can cross multiply to solve. And again, I was able to do that because I had two pairs of opposite angles and sides. So let's go ahead and cross multiply. So I'm going to get 40 sine 32 is equal to FG times sine 39. Put that in parentheses. And then I want to get FG by itself, so I'm going to divide by sine 39. And FG will equal whatever 40 times sine 32 is divided by sine 39. There's your exact answer, and I want to round to the nearest tenth. So go ahead and throw that into your calculator and see if you get about 33.7. Again, try to do your exact answer first because I want to see what's going into your calculator before you put it in your calculator. Okay? Take a look at part B. Now I want to find the measure of angle Q. And once again, how do you know when you can use a law of sines? It's when you've got opposite information, meaning you've got a pair of opposite sides and, sorry, two pairs of opposite sides and angles. One thing I forgot to put onto your printout, so you guys want to add this in yourself, PR should actually be 6. So we're going to pretend this was already in or on our papers. All right, so PR should be 6. So what you want to see is, do you have a pair of opposite sides and angles? So I've got a 57, and opposite 57 is 8. Awesome, that's what I mean by one pair of opposite sides. We want to see, do we have another pair? Well, remember, I'm looking for angle Q. So angle Q is an angle I'm focusing on, okay? And opposite angle Q is that 6. So awesome, I do have two pairs of opposite sides and angles. So now I can go ahead and be confident I can set up law of sines. So I can say sine of 57 over 8 is equal to sine Q over 6. So it doesn't matter if you're looking for sides or angles, you still want to set it up in this way. Go ahead and cross multiply now. So I'm going to get 6 sine 57 equals 8 times sine q. And I'm going to go ahead and divide by 8 because I want to solve for q. So I get 6 times sine 57 over 8 equals the sine of q. Remember, how do you get rid of the sine but keep q on the side? Well, remember, that's where the inverse function comes in. So the measure of angle q is equal to the inverse sine of 6 times sine 57 over 8. And then you can throw that into your calculator. All right, let's go ahead and round to the nearest degree. So the measure of angle q is approximately, what, 36 degrees? Yeah. All right. So don't be freaked out when you see this huge thing. Again, just put it into your calculator one at a time. So you can do 6 times sine 57, divide that by 8, and then take the inverse sine of that. Or if your calculator can handle it all in one line, just put it all in one line, keeping track of your parentheses.